Hey third graders, it's Miss Gante again, back with another science video, and you already know what time it is. It's time to use our brains and become scientists. Start off this video by remembering some characteristics of scientists. So start thinking about them in your brain. Take a second, let's get started. So as scientists, we need to wonder, we need to ask questions, we need to record our observations, and we always need to remember that science is not perfect. We need to persevere if we ever get stuck so that we can work to become problem solvers. Last week, we did a lab about soil retention. And if we're not feeling too confident about that, we had the 4 different types of soil and we poured a cup of water in each one. And then after we poured some water, we then observed which soils had the most water retention and the least water retention. So just reviewing those results that we had last week, we remember that sand had the least amount of water retention and loam had the most amount of water retention. So making that loam soil the best soil to plant flowers, vegetables, or any other types of plants that you can think of. Once again, this made my brain wonder, how does water affect rock? So we saw how water affected soil, but how does water affect rock? How does wind affect rock? And the last one that I was wondering of was, how are rocks and soil related? So we talked about rocks, we've talked about soil, but this is science. What do they have to do with each other? So right now I want you to take a moment to think. And you can write this down, you can pause the video, write this down in your science journal. What do rocks have to do with soil? Erosion is going to be the new word that we talk about today. Last week, our new word was retention, specifically water retention. Today, we're going to be talking about erosion. So I'm going to pop up the definition of erosion right here. Erosion, what is it? Erosion is a process where natural forces like water, wind, ice, and gravity, they wear away rocks and soil. So they wear them away. Today, as scientists, we are going to observe another science experiment. And this science experiment is going to answer the questions that we were talking about before. How does wind affect rock? How does water affect rock? And how are rock and soil related? Make sure you have your listening ears and get your pencil and your science journal or a pencil and a paper ready for what we're about to do. Because right now, we're about to travel over to my workstation. All right, everyone, so let's travel into our workstation for today. So I have my writing utensils. You're going to have your pencil and your learning journal. I have a cup that we're going to be using. I have some water. I have my yardstick. I have books, but not just any old books. I have our science books. I have trays. We have our measuring cup. We have our magnifying glass. And then we have our sand. I have explained all the different science materials. I want you to pause the video and write about what you think we're going to be doing today. Now we're back, and if you said that we're going to find out how erosion works, you are correct. We are going to use our sand and materials to create an erosion model. Let's get into it and start thinking like scientists. Are you ready at home? Usher, can I get a yeah? All right, boys and girls, so I'm ready. I am thinking like a scientist, and I hope you at home are doing it too, or at school are doing it too. So here are our questions that we're going to be thinking about throughout this whole experiment. How does water affect rock? How does water affect rock? How does wind affect rock? And then finally, how are rocks and soil related? Also, I want us to think about erosion. What is this lab that we're doing? How does it have erosion? What does it have to do with erosion? So I want us to think about that too, and I will add that on our chart. All right, boys and girls. So the first thing that we're gonna do is we're going to pour some sand into the pan so that it makes a layer that's about 2 to 3 inches deep. So if we're confused about 2 to 3 inches, I have my little mini ruler here with me, and here we got our 2 to 3 inches in our pan. But if you don't have access to this at home or at school, it is okay, because we can use our thumb. So general rule of thumb is our thumb is approximately, that means about, it's approximately the size of an inch. So what you can do is you can measure your thumb 2 to 3 times. So what I'm going to do now is I'm going to get my cup, get my sand, and I'm going to pour it into my pan. All right, boys and girls, so after we have poured our sand, if you can see our sand, I'm done with it. I have poured my sand into my tray. I have my little ruler, and I can stick it in, and it is right where we need it to be. So now, that is the first step. Then I'm going to smooth the sand and pat it down as even as possible on the top. So for that, I'm just gonna use the back of my measuring cup, and I'm gonna pat it down to be as even and flat as possible. I'm gonna bring you in. I want you to examine this sand closely. What does it look like? Bring in the magnifying glass so we can see it. Look at these big chunks. What are those black specks? Do we see that? What do we notice with the sand? So right now what I want you to do is, in your science journal, I want you to make some observations. It's gritty. It's not really too soft. Has rock clumps inside, so if you can see those, has those rock clumps. So right now, in your science journal, I want you to observe what you see. Write that down. I hope you can see it at home, but my next step was to use the sand to create a landform. So now, in social studies, you have talked about the different mountain ranges in the US. So what I created wasn't a mountain range, but I created my own little mountain full of sand. Now, in your writer's notebook, I want you to draw what this looks like. I want you to draw what Miss Gante just created. So I'm gonna give you some time to draw what you see in front of you. After I've given you some time to draw what you see in front of you, our next step is to slip 2 books under one side of the pan so that it's propped up and it's leaning. So I have not just any regular books, even though you can use regular books at home, science books. So I'm going to use them to prop it up on this side of the pan. So now you can see that it's leaning. So wait till I do the second one. Ooh, so now that it is officially on an incline, we're going to bring my yardstick and I'm positioning it so that it's at the top. It's kind of over my landform, but not really. And I'm gonna leave a few inches uncovered so you can see that. What I'm going to do is I'm gonna take my cup and I'm gonna poke a hole in it. You can poke a hole in your cup with a pencil. You can see that I am doing with a pen. No need to bring out any heavy, sharp tools or machinery. It should look like this. So there is a small hole in my cup. Now that I have balanced my cup on top of my yardstick, I have my books, I have my plane, I have my landform, I want you to pause this video again and draw what you see. So now, boys and girls, this is where you have to become problem solvers. You have to think, what is going to happen when I pour water into the cup and place the cup back on the yardstick? What do you think is going to happen? Before you watch this next part, hit pause and write what you think is going to happen. So hit pause now. So if you can see, the water is dripping down and it is affecting my landform. Let me bring you in closer. Do we see that? That water is coming in from the top and it is making some marks on my landform and it's still dripping. So let's make note of those observations. All right, boys and girls, so now all the water has officially dripped out of the cup. So now we're gonna look at what we can observe happened to my landform. All right, boys and girls, what do we notice now? What do we notice about my landform? Does it still look like a mountain? And I'm gonna zoom you in real close. You can see here, this is where the water droplets really impacted the sand. So now, how does water affect rock? So we're pretending that this was a landform, it was a mountain. How did water affect it? Write that down. And then if there was a windstorm that came, what's going on? What's happening? How does wind affect rock? And as you can see, bits and pieces over here, this will now be my new soil because the rock form that was there before has now been withered away into little individual pieces. And that brings me to our final question. What is erosion? All right, boys and girls, so now I'm going to ask you another question. What do you think would happen next time if you were to dump the whole cup of water instead of just having a hole punched in it and having it drip drop down? I want you to think about that for a second. How would that change our experiment? All right, boys and girls, so what we experimented with today was weathering and erosion. Because we have water storms, wind storms, ice storms, everything that impacts the earth, that cause affects how our rock and soil are created. Do we see that? So what it is essentially doing is these natural storms are taking the earth's crust and making it and breaking it down into smaller pieces of sediment. So we've talked about how rocks can become soil. So hand in hand, we have answered how are rocks and soil related? They're related because soil comes from rocks. And weathered rock is carried away or moved because of water or wind. So now, with all of that information that we have in our toolbox, I want you to make sure that you are writing this down in your science journal. So we have talked about erosion. We have talked about how water affects the rock. We have talked about how wind affects the rock. And we have talked about erosion. As usual, boys and girls, thank you so much for spending time with me today and doing this science experiment because we are scientists. I had fun with you guys today. I'll see you on the next one. Bye, guys.